Hey everyone, how are we doing today? It is Tuesday. Oh my gosh, it's a big week, right, Adam? Adam heard some news. Kayla, great to see you. Let me look at, I was in a meeting. Oh, look at that. Mewbot's saying hi to everybody. Mewbot's so quick to respond these days. I feel like my camera's cutting me off too much over here. Can't reach off the screen so much. Mewbot is so nice in the chat right there. Let's see. I'm going to reorient the screen. Abigail's checking some points there. If you got questions, let me know. And tell me how those graphics are looking, Kayla. We'll put on a little chill music right here in the background. I feel like I need more. Look at that. I should have more screen. Well, there's the issue. It's the green screen's not doing perfect. I can reach that far off the screen right there. Cassandra, good to see you here. If you're in the chat and you got questions, let me know. I'm going to go back to our messages. Although it seems like I'm not sure these shapes. Yeah, I think the shapes are good. Yeah. Oh, yes. I saw that with the HTML color codes on the volunteer one. I thought that was awesome. I think it looks very nice. Yeah, I think it looks great. Like I'm looking over the stuff we sent, Kayla, between. I think it's looking really great. I really like the color choices, the HTML color codes. Obviously, the fun one in the middle is more like funfetti. Much smaller word cloud, less active community. So great stuff right there. Yeah, I think the shapes are good. I think it adds some fun to it. Like you have a what's that? Rectangle? And random shape, and then a triangle for volunteers. I think it's a lot of fun. Maybe the only you could go for symmetry with the triangle, the rectangle on the other side. But I think it shows some fun and some levity and some interesting stuff. If you need me to fill out the other sections and make it look like the other one, I can help out with that. But if you like the way the graphics are in there, it looks great. Thank you so much, Adam. Yeah. Oh, he told the class this morning. That's awesome. That's such good news. I gotta look presentable. I'm getting my haircut tomorrow. I got a barber haircut. So I'm going to start to look more presentable. Chelsea looked last night. She's like, yeah, you do need a haircut. Because we were talking about me needing a haircut. And she's like, yeah, you need a haircut. And then I'll have to shave. Hey, Maria, good to see you here. If you got questions, let me know. We're just talking about some Milton Scholar stuff right now. Brian's realizing he needs to shave. Big day Saturday. Big day Saturday. I gotta look my best. Got the suit tailored. Got the tie, orange tie. So we got some orange. We're excited. What do you think about the bold words under result? Let me take a look at that right here. Let me take a look. The group sent you for $4.75. Let me take a look at that, Adam. Here we go. The bold words under results. Yeah, fluctuations in active involvement. I like that. That's a good way to end it, like on that. I think maybe another paragraph of text right there, just kind of filling it out. But I think that right there, yeah, exactly. To see when they're most active. Exactly. Because that's what we're looking at is how these communities are coming together or falling apart. So yeah, I know. I think that calling attention to certain words is key. When people are reading it, because people are going to walk by and be reading, the poster without you there. They're going to be walking by looking at your poster and being like, oh, interesting. Oh, interesting. Interesting. And so, yeah, I think that's the best thing. Let me see here, Adam. Where is it, Adam? Let me see here. Adam's asking about an email. If you're able to get these things like name, Milton, that would be great. Oh, yeah, the whole, I can get that done later tonight. Message me on the Discord about it. No, I won't forget. Peyton sent it. Oh, I think I did see something, and I hadn't replied to it yet because it's a grading thing. I think I did see it. It's about the features, right? So it's about the features. Oh yeah, everyone's CC'd on it. I know. Okay, because there was a feature was changed. So if you want, follow up on the email, in case, I just want to make sure. There we go. So Kayla, let me know. We'll keep that going. So Adam, so you're saying the feature was changed, right? Is that what happened right there? Yeah, no worries. But it's that the feature was changed, right? If you have questions, let me know. We can do some 201. Thank you everyone for being here. We're just chilling out right now. Brian's gonna drink some more coffee. Where's my coffee? We're out of coffee. Out of coffee. It looks like there was a feature change, and maybe they didn't see the feature. So you had a feature, but they didn't see it, so they took off points because they thought a feature wasn't there. So the points, is this correct, Adam? I might be able to take a look at it now. Maybe I won't talk about what happens, so that way no one knows the grading. Let me see here. We'll put a little chill music on in the background. But is that an accurate description? Let me go take a look. And sorry it took a while on the grades. I appreciate graders have been working hard. And let me go. I'm going to go find this right now. But if you have questions, let me know. Let's see here. Adam will tell us. There we go. Take a look right here. Where's it getting caught up? Okay, here it is. I'm pulling it up as we're taking a look. We were a little confused as to why that was. Okay, good. So there was a change in features. Okay. Let me look. So they completely took off all the points for one feature. And they just said like it's missing. Okay. And there's comments on that. Okay, so they said it's missing. So let me see if I agree with the grading. I'm not gonna say what the grading is, but I'm gonna take a look right here. Okay, one moment. I'm downloading the repo. What? Come on, don't do that. Open a new tab. And if you have questions, let us know. I think I already have it. I've already forked it one time. Forked everyone's repo. Yeah, okay. I'm getting it right now. Cloning the repo. Could you go over the Philanthropic? Of course. Who will do that next? You bet. I'm opening up the app. Okay. Possible features. Let me see. Okay, I am opening. Wait. I am opening up everything right now. Oh. What? Running into some issues, Adam. Let's see. Okay. Is it updating? Oh, it is. It's updating dynamically. Cool. I think the one thing I see. Okay, I see 1, 2, 3, 4. I think the theme changer is 1. So here I'm gonna go back to the regrading. I'm gonna put some new notes on this, so they can read the notes. Okay, so let me go in here. There is theme. Okay, they added a note right there. Theme changer. Let me see. 2 seconds here. I'm going to do the. I'm making sure I grade by the rubric. Do we go? Changer an app. Theme changer could be more complex. Okay. I have made adjustments and changes. I think that's pretty good right there. So let me know Awesome office hours. Let's do some philanthropic organizations closing down R. Got a lot of versions of R open. But it is time. Now I'm closing down all the files I got. Let's see. I can keep that open. We have the philanthropic. Oh, no, fine. That's fine. I made some changes. Go check out the changes. Let me know. Oh, I forgot my virtual camera's still going. I was in a bunch of meetings this morning. Woo, meetings. Bunch of meetings. Can you go over the philanthropic organizations? Confidence intervals. Let's do it. Make sure. Okay, got everything good to go. Oy. It is busy. Who has had a busy semester? Whose semester you're like, oh my gosh, we're nearing the end. It's been busy, and then we got mini term. Woof, woof, mini term. Mini term coming up here soon. Got to get stuff set up for mini term. Got to go on honeymoon here. Got to figure out where should we go on the honeymoon. Such a busy time. We're loading up the philanthropic organizations right now. And so chapter 13, homework, replace questions, philanthropic organization. I think they're trying to estimate the mailers. Find out right here in a moment. Philanthropic organization. A philanthropic organization. Here we go. Okay, so Cassandra, get ready. I'm going to need your help here on these. We're going to do the philanthropic organization. So, Stat 201, Chapter 13, Philanthropic. How in the world do you spell that? Philanthropic organization. Okay, so here we go. Let's do it. Oh, no. Got the 80s effect on. Nope. Okay, so the philanthropic organization question, the number one thing to do is whenever we get a question, we need Leo here to help out. We must first mark down our what. The number one thing, and I need someone's help with this. I need to know what is the number one thing we do whenever we get a question. So what do we do for 100 points? We haven't even given any points, so we just got to give some right there. What do we do whenever we get a question? The first thing we do is we start marking the what. So what do we do? Take a moment if you're watching this in the future. The future. The future. I don't have a... The future. There we go. It's a better effect. What do we do? How do I start this problem? Notation! Kayla, to the rescue. Notation, exactly. Mark your notation. So let's start doing this. Get that energy into you right back right there. So we're going to take and mark this as sample size. That's how many people they reached out to. This is X. A lot of people forget this one because X is the amount of successes in a sample. This is a categorical question. Did people respond to the mailer? And we're trying to estimate, okay, so we're this huge philanthropic organization, apparently maybe reaching out to the United States. And we send out 100,000 mailers to people in the United States. And we want to know what is the true proportion of people who will respond to our mailer. It's a crazy sample size. Now, since the United States is probably about, I think, 330 million people, we're assuming, I know the question doesn't say it, but this would be the population size right here. So this is less than 10%. So we're good on the 10% condition. We're good on the random condition. And then last but not least, we have at least 10 successes, at least 10 failures in the sample. Now, interestingly enough, NP hat is actually equal to X. So we actually have at least this many successes. The amount of failures is simply the remaining out of 100,000. So if we go right here and take the remaining amount of failures in the problem, we're just checking the conditions right now. The remaining are the amount of people who did not respond to our mailer. So there's the 100,000. Then we subtract out the people who did not respond, and it's 94,958. So this is NQ hat is equal to 94,958. And so we do have at least 10 people in our sample who responded yes, and at least 10 people in our sample who responded no. Now, you might be wondering, well, what is P hat? P hat for this problem is nice and neat because P hat is X over N. X in this problem is the number of successes, i.e. 5,042. And N is the number of failures, or, oh my gosh, N is the number of trials. Successes would be how many people responded yes that they're going to do this, and then The sample size minus, as we did right here, is the number of people who did not respond. So this as a percent is merely, or a decimal. Why not a decimal today? Ooh, watch it if I make some errors, or my O's don't look like O's. I'm still learning how to write. That is the percent, because we're dividing by 100,000, so it's a movement of decimals. So 5.042% responded. So when you think about this problem theoretically, what we have right here is we are trying to estimate the true proportion of people who will respond if we sent this to like everybody, like all people in America. Very large. And it says make a 99% confidence interval, and this is usually where people get stuck. One letter in the chat. We need the what score? Snea! Oh, thank you. Double congratulations for you. Snea, so many great things with the MBA program, or MSBA, excuse me. Thank you so much, Snea. You are doing great. And I think I can tell you this. I nominated you for an award, but they're looking for juniors and sophomores. But I nominated you. I just want you to know that. Maybe an award named after somebody. But I put in a nomination. They said, oh, we're looking for juniors and sophomores. And I said, oh, I've been trying to nominate so many people. I did nominate a few people. The people who've moved on, I might not say, but they're looking for juniors and sophomores for an award that I've heard about named after a certain individual. But I'm honored by your words, and you're doing an amazing job. And so keep it up, Snea. Yeah, great job. And congratulations to you also. So yeah, her dress is like 5 feet away from me. Saturday. Woo! Busy day. So this there is P hat. That there is P hat, as we say down here in the South. And oh yeah, no, it's so cool. I heard it's up in Haslam, like my picture's over there, and I'm just like Brian Stevens. So we're looking for the Z-score right here. The Z-score is going to be found via the David M. Lane applet. The David M. Lane applet is where we can go to look up Z-scores. Z-scores are always going to be consistent. The Z-score for this is going to be 2.5758. Just because I've done this many, many times. But what does this mean? Why is it 2.5758? Well, and we'll see it on the applet here in a second. Hence, you'd use the applet to solve this. On the test, we will just give you this. We will flat out just tell you the Z-score is this. It will just say it. On the applet, it's going to say 2.576. But since it's always this for a 99% confidence interval, and I've done these problems multiple times, I know that this is the Z-score. You should be able to kind of deduce what the Z-score is close to, though, because we know that 95% of the area on the curve, it's not quite 95. 95% of the area on the curve is within a z-score of -2 and +2. That's the middle 95. The middle 99.7 is within -3 and +3. So that's the middle 99.7. And so you would deduce that this number, that is the 99%, we'll put 99% right here, the 99% shaded on the curve would have to be between a z-score between 2 and 3, because at 2 you've shaded the middle 95, and at 3 you've shaded the middle 99.7. And we'll show that here visually, but we could deduce that the z-score has to be between these numbers. And so let's go over here, and this is how to look it up on the applet. You want to go to the second button, and then go to the between button, and now put in the area you want. As in, if we wanted a 95% confidence interval, it's actually 1.96. That's the direct z-score. We usually just say 2 if we're calculating in our heads, because it's basically 2. Basically. All programs will find you the exact answer, though, and we will tell you 1.96 on the test. We also mentioned that 99.7 is basically 3. It's 99.73 if you want to be exact, and then it will say 3 on the applet. But we don't want these numbers here. We want a 99%, and that is 2.5758, or rounds to 2.576. But if your question were to ask you something like a 90%, 1.645, or 98%, 2.3263, these are all numbers that if you do stats long enough, you start to memorize, which you don't have to. On the test, so I want to make this very clear, on the test, we will just tell you the z-score for a 99% confidence interval is 2.57, probably will say 6. We just tell you those answers flat out, but you should understand theoretically where they're coming from. It's the amount of area shaded on the curve. So all this stuff right here has now led us to solving this question. The equation we need to solve, so we'll put it in green here, meaning the good equation we need to solve, is going to be p hat plus or minus the z-score, p hat times q hat. Notice how we're using p hat and q hat here because we don't know the truth. We're trying to estimate what the truth might be. P hat times q hat over n square root, kind of like p times q over n square root. And so now let's go in here and put in our p hat. Oh, so many decimals. 4.2 plus or minus the z-score. This one's more just like the decimals are not fun in this problem. And now we got to do 1 minus that because that's q hat. So, or we just divide this by, there we go, and make sure these add up to 1, 94958. There we go. I'll disappear here for a moment. And we're divided by 100,000 sample size. And that is the standard error. So this is the standard error right here. So we'll just put a note right here. This is the standard error. Really? I hate it that it does that. That is known as the standard error of the equation. Standard error of p hat to be specific, just in notation. This is the z-score. Together, these two things make up what is called the margin of error. So when you think about this, right here is known as margin of error. So we'll put ME. That whole quantity is the margin of error. The first part of the interval is actually the center of the interval, and that is the estimate we get from p hat. And p hat is known as the center. So we'll abbreviate here as center. It's basically the best estimate, center estimate. So you can call it the center of the interval. So now what we're going to do is usually I just solve for this quantity margin of error. And so let's solve for what the margin of error is over here. Okay, to solve the margin of error, we take q hat, we can times it by p hat. We're just solving the top part of this equation right now. Divided by 1, 2, 1, 2, 3, divided by n. Square root's going to be a tiny little decimal. Times, and please note, this is in scientific notation right now. Times that by the z-score of 2.5758, whatever z-score you found, and this is the margin of error. So what I'd probably do at this point, 0.00178. We're going to take and just put the margin of error right there as a whole quantity. And now we're going to take the center right here and actually put the value at the center. 0.05042 plus or minus. And there we go. Let me see, content attachment. Oh, yeah, no. Such good news. It's so good. People are sending me really nice stuff. I love it. And so now we're just going to add and subtract because now all we do is we take 0.05042 plus this. There it is right there. That's the upper of the interval. And so 5.22. And it seems like it's, I guess that's right. And 0.05042, we're doing p hat minus 4.86. That seems right. Seems right. Nice work. Do you think 4.8 is plausible? Now, when would we think something is plausible? So we're saying, I think the truth is somewhere between 4.86 to 5.22. And I know 4.8 is kind of close to those numbers, but that's not how we do it. It's like, I think this will cost between $4.86 and $5.22. And I say, do you have enough money if you have $4.80? And you say, I almost have enough. And you say, no, but you don't. I'm sorry. It's not inside the interval. So we don't think it's plausible because it's not a possible value. The interval gives us what we think the truth might be. And I'm 99% confident the true proportion of people who will respond to this mailer is contained in the interval 4.86 to 5.22. Please note the way I worded that right there. That's sampling distributions. Do I have the notes open from yesterday? I do. So, oh no, do I not? Where are my notes from yesterday? Chapter 13. There we go, conference roles. Okay, we're reopening the notes from yesterday. Let's go down to the interpretation right here. Ooh. So I am blank % confident that the true blank is contained in the interval blank to blank. So I like to say I am. This is my preferred method. If you say we are, that's fine. Blank % confident that the true, and I usually add true right here, true blank is contained in the interval blank to blank. If you notice the way I read this right here, this is stuff you need to know for the test, so make sure to write this down. I am saying I am 99% confident that the true proportion of people who will respond to the mailer is contained in the interval 4.86 to 5.22. Know how to do those interpretations. I am 99% confident, state your confidence level, that, and then state what you're talking about, that the true proportion of people who will respond to the mailer is contained in the interval 4.86 to 5.22. And we have the format right here. I like to say I am. You can say we are. But I am blank percent confident that the true, and you have to state the population parameter, the true population proportion of people who will respond to the mailer. So you have to talk about what you're talking about. This is usually where the mistakes happen, is contained in the interval blank to blank. This is the hardest part. Usually that's where I see students making a mistake because it says, I am 99% confident that the true proportion of people who respond to the mailer in the population is contained in the interval blank to blank. I don't just say population here, but I say the true proportion of people who respond to the mailer, which does mean population. Or you could say population proportion of people who respond to the mailer. So practice this, know how to say it. This is the hardest part where we usually see the errors because it's what are we talking about? And we're just trying to figure out what proportion of people will respond to the mailer. So we took a sample. We found out in the sample 5.042% responded. So I think the true percent or proportion that will respond is somewhere in the interval 4.86 to 5.22, and I have 99% confidence in that interval. Well, that's got it. We don't have any more questions right now. Who's got questions? We got 320 work. We got 475. We got class coming up here in a little bit. What questions do you have? Let me know. We'll head back here to the main screen. What questions? We only have one question today so far. No! What questions are there? Who's doing some work? What do we got? 320, 475. If you're watching right now, let us know. I thought you used to tell me how many people are watching. I'm scared. Say, I'm super excited. I get to see my parents. I haven't seen my parents in 2 years. Well, I've seen them on like Zoom. So, I mean, does that count? I haven't seen them in person in 2 years. That's crazy. It's the longest I've gone in my life without seeing my brother, my sister. I haven't seen my brother in 2.5 years. My sister was the last person I saw in Knoxville before I left. Sad right there. She won't be here. We're having a very small wedding. So, very small. But it's exciting. It's super exciting. So it's busy, 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 busy. My parents get in Thursday night. More families coming in Thursday. Thursday's the big day when everyone gets here. So I'll be teaching until Thursday evening. And then Friday, I'm not doing anything. Friday, it's like not doing anything. Just making sure. We're also cooking taco meat on Thursday night to prepare for, we're doing a picnic on Friday. We rented out like a pavilion area. So we're doing a picnic on Friday. We're doing sandwiches on Saturday. I'm hoping like definitely maybe this summer. That'd be really nice, Snea. I'm trying to work it out. The department would be a good time. And Dr. Galbraith, who's actually just so amazing, has offered at any point for me to stay at his house. He's like, hey, look, we got this basement right here. You can come visit us. You can come stay with us, fly in and you can stay in our basement. Just like, it's all yours. Just hang out, relax. So if you haven't met Dr. Galbraith, who's our department head, I mean, what department head is like, hey, come stay at my house. You want to stay a week? Whenever? You want to just live here? I mean, he didn't say I could live there. I didn't take it that far. But he's been so kind. He said, so where it's like, so where are you living when you come back to Knoxville? He's definitely up for me visiting, and that's just very kind to extend the offer. But that's really awesome. And so he'd be able to drive me to campus. I'd just be like a kid, going to campus. Just like not like kids go to campus, but I mean like when you're a kid and you go to school and your parents just drive you to school, and so you just wake up, you get in the car, your parents drive you to school. It's like nowadays I gotta drive myself everywhere. I gotta do the adult thing. So it's nice when you're growing up. Yeah, that's awesome. Yeah. Well, you'll with the MBA and stuff, right? Or MSBA, excuse me. It's I'm excited. I really want to see my students and like go to my office. And I almost figured it'd be funny if I was just walking around campus and people were like, Brian? And I'm not saying like I don't think I'm some celebrity. I don't think that. But I realize it's easier for someone to know who I am without me knowing who someone is these days, because like I don't mean it bad, Snea, but you could walk by and I'd just be like, doo-doo-doo. Here's what you'd see. I'd be like playing Pokemon Go. I'd be like, boop, 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 Pokemon Go, patching Pokemon. And someone's like, Brian, I'd be like, hey, what's up? And you'd be like, I'm Snea. I'd be like, hey, Snea. I'd be like, so good to meet you. That's how it would go. That's the interaction. Because I don't know my students, and that brings me sadness. Usually I can see my students and be like, hey, so-and-so. Like, a lot of students were giving me nice words like Greg, and I've got to respond to more people on LinkedIn. Yeah, the Brian on the coat hanger, right? That Charlie set up. Like Greg and Whitney. There were so many students talking on that. Dominique. There were so many students. We're setting something up with Dustin. Dustin has had a really awesome career. I don't know if he's doing a PhD now or what, but he's thought about doing a PhD. He was messaging me on LinkedIn. If you saw those messages, yeah, exactly. It's like and it's not like, oh, people would recognize me on campus. It just happened before I even left. Where funny enough, the funniest time someone actually recognized me, it wasn't by seeing me. I was on Ped Walkway and I was talking, and I was just like, I talk to like random people on Ped Walkway. If there's someone out there doing something, usually I'll just talk to random people. It's just fun. And so I was talking to this person, and this lady goes, "Are you Brian Stevens?" And I was like, yes, I am. And she goes, "My daughter's in your class." And I was like, okay. And she's like, "No, I hear you talk all the time. You're always doing some big example or something." And that's the funniest time I've ever been like recognized. No, it also happened at Starbucks too. I was in Starbucks with my fiance, and she was just like, because I was just like talking just like to her or something, and someone turned around and just looked at me, and I was like, that's weird. People just, hopefully I'm not being too loud. And then they turn around and they go, "Are you Brian Stevens?" And I was like, "Yes." And they're like, "My friend's in your class." They're like, "I hear you on the computer." Things like that have cracked me up, and it's just funny to like, it's fun. I miss being around campus. I miss seeing students just walk around playing Pokemon Go. One of the funniest things is like I was playing Pokemon Go with some people. You heard it here first, Brian. Well, I think it's the way I talk sometimes. I'm very boisterous, and I'm that way in person sometimes too. So I can get to that like, more of a show level that I'm here sometimes online. But I'm still this way in person too. I'm not like a totally different person online, but a funny thing is I play Pokemon Go on campus. So I'll be walking around with like some people playing Pokemon Go. Sometimes they're students and stuff like that, because it's like, we just walk around and play Pokemon Go. Someone's like, "Hey, let's go do this raid." And I'm like, "Okay, cool, let's go do it." So then I'm playing Pokemon Go, and we went to like a raid, and we were like, "Oh, awesome." And my name on Pokemon Go is Brian Satoshi, because on the Pokemon Go in Japan, he's Ash Satoshi, or Satoshi's his name. So I wanted to be like Brian Ketchum, but everyone took that name immediately. So I was like, "Oh yeah, Brian Satoshi." It's because it's an S also, so I'm Brian S. So I thought that'd be a good name on Pokemon Go for my character. And so people will just call me like Satoshi or Brian Satoshi or like random things like that, or they know I'm Brian, so they know my actual name too. But we were playing Pokemon Go, and someone's like, "Do you teach here?" And I was like, "Yeah." And they're like, are you a stats teacher?" And other people are like, "What, he teaches here?" And I'm like, "Yeah, I teach here." And so it's been some interesting interactions. It's been some like randomly someone's like, "Wait, are you faculty here?" And maybe as I get older, they'll be like, "You're not a student here, are you?" So sometimes they think I'm a student in something. I'm like, "Yeah, it's fine. I'm a student, whatever." But I miss it. I miss there's a lot of great people in the Pokemon Go community, like Mel. She works in the engineering department. No, she works in Mingcow, I believe. Just missing all my old Pokemon Go friends. Sad music right here. But if you have questions, let me know. Here, I'm gonna build up the taking questions moments on here. But Mel and her husband Dale, I think it's Dale's her husband. People have thought I'm a student multiple times, especially like I like debating people. Like, if you notice online, I don't debate topics. I'm not here to debate topics when it comes to class. I try to present everything in an unbiased manner, but I'm actually really big into debate. I love debate. I love challenging ideas. I love having my ideas challenged. There's many interesting people who come by campus with big ideas, and like, so if I see someone out on Ped Walkway, and I've definitely had people think I was a student. One person, when I was having a conversation with someone, we were kind of debating ideas. They were like, "I need to see both your IDs and know that you're students here." And I was like, what? And they're like, I'm faculty. And I was like, okay, here's my ID. I'm faculty too. 1D, sure, Parker, you got it. We'll load that up here. But they were just, I was like, hey, we're just having a nice talk. Like, we're just having a great time. Just conversing about ideas, which is awesome. I love the exchange of ideas. To me, it's interesting to like hear a different viewpoint. I'm not saying I'll then agree with that viewpoint, but I think it's fun to, in my personal opinion, someone who loves debate, it's fun when someone's like, you're wrong. I'm like, oh, why am I wrong? Do tell. Do tell. Can you convince me of that? So I think, and we do it here differently. That's why we take data. Let's talk about some data right here. Our whole discipline of business analytics is on the idea of bringing data and challenging ideas. So we're segueing into the next topic right here of assignment 320. So let me take the timestamp on this. Parker, thank you so much. Parker, 100 points. We're going to go back on topic here. We got music playing and everything. I know you get to learn new things. You get to challenge ideas. You get to move forward your knowledge. Got some just exciting music right here. Yeah, anytime someone challenges my ideas, I'm like, that's great. Let's see here. Assignment 9. Let's challenge our ideas. We'll pretend we got to debate someone on this. 1D. Let's go challenge ideas over here. Here we go. Okay. I just love this right here. Okay, so we work for a bike organization. Let's load in the data. What are they challenging our ideas on? That's from yesterday. Okay. So that's all the stuff we did yesterday. We got the Homework 9 bike data loaded in. What have they challenged us on? Demand for bike may fluctuate with humidity. Really? Really? You really believe demand for... is not... Gotta go, Snea. So good to see you here. Thank you so much. And congratulations to you, Snea. Excellent work. And keep it up. You're awesome. 100 points, Snea. So let us consider the variable humidity. Demand for bikes. We're looking at bike kiosks here, and we've been tasked with understanding the relationship with demand and humidity. Humidity has 3 levels. Ooh. So this means it's a what type of variable? Humidity. So Parker, help me out right here. Humidity has 3 levels, which means it's a what? Now, we don't call it a factor, but call it some tool 1 knowledge here. We haven't used this in a long time.
Know your variable types.
So what kind of variable is humidity? So it is called a factor. That is the name it goes by. But let's call it something, better than factor. Let's call it its usual name that we talk about, not the qualitative thing, though, because that's always confused me. I mean, I know what qualitative is, but I never liked that. I prefer to call these quantitative right here for numeric, and I prefer to call those what? Oh, that's all right, Parker. Think of a C word. Think of not a dog, but a what? So I'll help you out right here. We're not looking for quantitative. We're looking for the C word, not a dog, but the other type of animal, something more on the end of it right there. So we're talking about the variable type right here. Categorical. Parker, 100 points right there. So this is going to create what's called indicator regression. Now, if we have a 3-level variable, how many indicators will that create? This is good practice for the test. If we have a 3-level categorical variable, how many indicators will that create? Hint, there's always one reference level. So that, out of the 3, how many indicator variables will there be if we have a 3-level categorical variable? When we create this model right here, no, there'll be 2. So no, don't worry there, Parker. Great answers, good practice. So the way it works is, you see how there's 3 levels right there? So one of them becomes the reference level, and the one that becomes the reference level is always what alphabetical. So when we look at this right here and we make our model, let's go ahead and make a model with this. We'll see that one of them did become the reference level. We're going to go here and add a chunk. And, yeah, good practice, Parker. And we're going to add a model here where we predict demand from humidity. It doesn't autocomplete. I could make it the other one. Data equals HW9. There we go. That's the graphics error because I got some graphics it doesn't like. And rerun it. Everything's fine. That was a warning message. Whatever comes first alphabetically is the reference. Parker, amazing work right there. You are correct. So you are correct. The reference level is the first alphabetical, and we do not see the reference level. So the reference level is not something we see in this output because each of these is compared to the reference level. So which of these has the lowest demand? Which of these humidity levels has the lowest demand? Low, high, or moderate humidity? Which of these has the lowest demand? So which of these has the lowest demand? Low, high, or moderate? And how would you know that? Which of these has the lowest demand? Low, high, or moderate? These are good questions right here, good practice questions as we go through here and kind of work the problem by explaining what's going on with the output. So which of these has the... good guess, good guess. High has the lowest demand. And the reason high has the lowest demand is because this coefficient right here is a comparison to the reference level, meaning 2 days where one day has low humidity and the other day has high humidity. The day with low humidity is expected to have demand 1,030 units of bikes more than the high day. So the reason we call it the reference level and you don't see it is because these coefficients are a comparison. So the positive coefficient means that there's higher demand than the reference level. To kind of show this also, we're not doing day, but let's look at day because day has more levels. Notice how there are how many days of the week? 7, but there's how many indicators? This is good practice right here, Parker. How many indicators are there? How many indicators are there? And I'm going to ask good, tricky questions right here, and then we'll see it in the output here in a moment. Might not be able to see it. How many indicators are there? So this is day of the week, 7 levels. How many indicators variables are there? Close, close, close. Since there's 7 days of the week, there's 6 indicators, and there's 1 reference. There's, if you notice right here, 1, 2, 3, 4, 5, 6. The only day missing is what? Good practice with it here. 7 days of the week, 6 indicators, because one of them becomes the reference. And the only day of the week missing, look at the days of the week right there, is what day of the week, which is the first alphabetical. The only day of the week missing is what day of the week, which is what alphabetical. I'm going to ask 2 follow-up questions here to make sure we really get this down. This is really good practice on understanding what the output's showing you to know for the test. The only day of the week is what missing right here? Friday. So which day has the highest predicted demand? So look at the output right here, Parker, and tell me which day of the week has the highest predicted demand. So which day of the week has the highest predicted demand? Got 2 more questions after this because this will really hopefully secure the knowledge of what all this means. Which day has the highest predicted demand? Thursday, you are correct. Thursday, you are correct. And this second to last question here. What does that coefficient mean? What does 3.656 mean? Like, remember, reference the reference level. What does the coefficient 3.656 mean? What does the coefficient 3.656 mean? That the demand for Thursday is what to what? So the demand for Thursday is what to what? This is the tougher question. Yep. And so this means pretty much, it means that is the difference between it and the reference level. And since it's positive, that means demand for Thursday is 3.656 units higher than the demand for Friday. So the last question is, what day has the second most highest average demand? What day has the second highest average demand? What day of the week has the second highest average demand? And this is where, if you really get it, don't worry if you get it wrong. I'm throwing 100 points here just for positivity. What day of the week has the second highest average demand? And if you get it, it's like, yes. If you don't worry. What day of the week has the second? It's Friday, actually. The reason that it's Friday is because Friday has a coefficient of 0, basically. We don't see Friday because everything else is compared to Friday. So Tuesday is actually less than Friday. Does that make sense? So Thursday is the only day of the week that's more than Friday, and Tuesday is less than Friday, which means Friday would be the second highest. Does that make sense? Because the only day higher than Friday is Thursday. Tuesday is lower. That's what the negative coefficient means, is that Tuesday's demand is on average 85 units lower than Friday. Does that make sense? So it would go Thursday, then Friday, because Friday has a coefficient of 0, basically. So if you think of Friday or the reference level having a coefficient of 0, and we change the output back, the day of the week with the lowest demand is going to be the high humidity, or not day anymore, but the humidity with the lowest demand is high humidity because it basically has a coefficient of 0. Does that make sense, Parker? Let me know if it's making sense. You don't see the reference level. It has a coefficient of 0, basically. These are comparisons where humidity is this much higher. Low humidity is this much higher than high humidity, and moderate has the highest demand. Awesome, Parker. Good work. It's a new thing, so we're practicing and getting good at it. Humidity is 3 levels. Behind the scenes, how many indicator? I think we kind of answered those, so make sure to review what we have in the output. Fifth regression model predicting demand from temp and humidity. Now, one of the reasons we do this is because it won't plot without it. Now, one thing to know graphically, and we still have the same sort of relationship. Ooh, those lines are going to be close. What we're going to see right here is let me see here. It's got a positive relationship. So we're going to see an upward slope to the line. Ooh, can't do it. Can't do it. Up. We're going to see an upward sloping line. I can draw it if I want. Here, I'm going to draw it here. You ready? Okay. So what we're going to see is we're going to see a black line. Oh, it's not black. There it is. Like that. And then we're going to see a red, and I don't have green pen. So we'll do blue. They're going to be very close. That's what we're going to see. Reason being is low and moderate are very similar. There's a positive slope to temp. So it's on the bottom here, it's going to say temp. And then over here, it's going to say demand. So we're going to see that there is a pretty big difference between the reference level, which is the black line. It just codes it black by the way the code works. And then the next two colors, I think, in the vector, it uses are red and green. So when we run the visualized model right here, let's see if we see something similar to this. And there it is. And that's pretty similar. So remember I said we'd see a black line that's a little bit lower. There's our lower black line and two lines that are basically on top of each other right there. And as I said, they'd be red and green respectively. The black line is the reference level, which is very different. And if you notice at the coefficients right here, remember we don't see high because these are differences, as in these lines are about 1,100 units higher. 2 days that are otherwise identical in temperature are expected to differ in their demand by 1,134 when one day has high humidity and one day has moderate humidity. So does not have an identifier. We did that. To use the visualized model after accounting for which humidity looks to have the highest. I'm not going to quite answer that, but definitely look at the coefficients right here. Why would I be getting an error on my visualized model? Make sure your code, I'll drop this in the chat, Parker. Make sure it looks just like this. You might not have. You should also have an error on the summarize then. I've dropped that in the chat, Parker. Make sure your code's just like that. You might have a capitalization error. That's probably the most common issue, is that maybe there's not a capital H, capital D, capital T. Homework 9 might not be capitalized. If you tell me the error you're getting, that'll help too. I can take a look. But a lot of times it's capitalization or comma. If your summary works, if your summary gives you the output, I'm going to delete that from the chat. But tell me if there's an error. Yeah, called it. Good work, Parker. It's very common error. One way to not run into capitalization errors is to do a trick that Dr. Petrie doesn't like, so we'll do it. Sorry, Petrie. Is to do attaches the vectors to the global environment. So now you can get the autocomplete on them. It's just it can cause issues if you have things named the same thing. But that'll give you autocompletes. It's not horrible to do, but it's not horrible to do. Petrie doesn't like it. I'm sorry, Petrie. Examine the results of the summary. Write out the implicit equations. So let's write some. Well, let's just do it here. Why not? We got some time. Let's write out the implicit equations because what we're going to do is we're going to take, and how do we do this, Parker? How do we do it? Do you know the saying where I say this, and then what's the next word? So what's the saying we use? Because it's the same way we write out the equation every time. We always write the overall, and then we write out the next line. So what do we say? Yes, you know, it's like this. What do we say? So we want to write out the equation. And a lot of people think it's harder than it is. I shouldn't keep saying that. But once you know it, you're like, it's just the same thing each time. I had these epiphany moments when I was in school. I was like, I'm just literally doing this plus this times this plus this. And what are we saying? We're saying the intercept. So let's say we're predicting demand right here because we want to know how much the demand of the bikes will be, hence the graphic. And we're doing LaTeX coding right here. This will put nice little good ways of writing. It looks like an actual equation. And we're going to take the intercept plus, and then you just do this times this plus this times this plus this times this. Exactly. Intercept. Great job, Parker. Yep. You just go algorithmically. The intercept doesn't have an x variable with it. It's just a constant value in mathematics. And so we're just literally going to go through here and take and multiply through each one. So we could go through here. I guess it can look like that if you want, and do the following. We'll write the full equation. We might not do the rest. It might leave people off, and then we'll talk about how to do the rest. But you literally just go through here and take each one, multiply it by the name of the variable, and this will give you the equation. So you can do a lot of copy pasting. It's going to be the quickest way to do it. This plus this times this plus this times this plus this times this. And just make sure to go through and grab each one, and you'll have it. Yeah, not that bad. It's once you realize the process, it's just adding everything up and multiplying each thing by its x variable, and then you get your nice, neat equation. Now, an important thing to know about this is that we have two types of variables in here. Temp is a quantitative because it's like, what is the temperature in degrees Celsius today? So temp is quantitative where humidity is indicators because it's either moderate, low, or high. So indicator variables can only take on what or what values. So indicator variables can only take on what or what values. I'm probably not going to do the rest of this, but Parker asked more questions. Then if you have more questions, we could do some other parts of this. Indicators can only take on what or what values. Zeros or one, exactly. And so if I want to write the low line, I set low to 1 and then reduce and solve. You know, that's 0, so it goes away. This will change the intercept right here. So make sure to solve. As you notice, these lines have different intercepts. That's the difference we're seeing in the lines, is the difference in the indicator. How would I solve here for the high line? So like mathematically or theoretically, what am I going to do to solve this for the high equation, Parker, for humidity equals to high? What would I do with the mathematics here to be like, okay, I want to solve for humidity is high. What is the steps for doing that? I'll reduce the equation after doing it, but this is right now the overall. Oh, it says high. This is the overall equation. That is not the high equation yet. What would I do to solve for humidity equals high? Like when there's high humidity. What would I do? So I've got this equation. I'll need to reduce it if I make changes to it. But what would I do to solve for the high humidity level? What would I do? I would take and I'd plug in what? Remember, we can plug in zeros and ones. So it's not low humidity, and it's not moderate humidity, excuse me. Correct. We put in zeros or ones. So is it, answer yes or no to this, it's high humidity. Is it low humidity? So it's currently high humidity. Oh, we don't do anything to temp because we don't know the temp. We're just solving for the implicit equation of like high humidity. So good answers, Parker. Good work. So let me ask you this. It's high humidity. Yes or no, is it low humidity? Just yes or no to that. It's high humidity currently. Is it low humidity? And they can't be both. So it's high humidity. No. 0. It's high humidity. Is it moderate humidity outside? It's currently high humidity. And it can't be both. It's high humidity. Is it moderate humidity right now? Like I look out today and I'm like, ooh, it's high humidity today. So we're just saying today is high humidity. No. And that's how indicators work. You put in zeros or one, whether or not it is. And you can't have for one categorical variable multiple indicators on, like it can't be Monday and Tuesday at the same time, like the day identifier, or excuse me, not identifier, indicator, I-words in statistics. Does that make sense, Parker? Why I'm doing that is I'm plugging in zeros because it's currently high humidity and it's not low or moderate humidity. This equation will solve out for the high humidity line. As you notice, there is a temperature in this because the temperature gives the slope to the line. So the slope of all these lines will be constant, i.e. this over here. The lines will just have different intercepts where we will either add these values to it. These values, this 973 is actually the intercept for the black line, that 973 right there. But the intercept for these lines are that much higher. So literally these are constant change to the mathematical models to increase the intercept, but the slope does not change. We don't plug in anything for temperature because these lines are the implicit lines where we can solve using temperature, whether the day has high humidity, low humidity, or moderate humidity. And these are so close because these values are just so very close. They're both about 1,100 above the 973 intercept down here. So their intercept should be in the 2,000 something, like 2,100. Is that making more sense, Parker, on what this equation is solving for when you reduce it? i.e. this is no longer the overall. It would reduce to this right here. So when we reduce the equation, you can see you should get a line that solves for an intercept down here about 973 where it would hit. And then the increase right here is a slope of 134. Oh my gosh, I was seeing that 7 at the end. And it's constant slope or parallel slopes for all of these. How's that looking, Parker? What are your thoughts? Is it making sense what we're doing here by fitting 3 different lines? And we've challenged the idea that you can use can't use quantitative variables. So for moderate humidity, it would be a 1, and it'd be a 1 where? So you are correct. So for moderate humidity, what would I do to solve for the line for moderate humidity? What would I do? So I need to do 2 things for this. You are correct, Parker. For moderate humidity, there is a 1. And so how do I then indicate its moderate humidity? In place of and then what else do I do? What else do I do? So just Parker, great job. Parker, that's for some 500 points. Great job, Parker. Is it making more sense how to use these, like how we solve these, and you're indicating it's moderate humidity. Hence, we call it indicator variables. So you're being like, it is moderate humidity today. I'm saying yes to that question. So these are just questions like, is humidity moderate? And you're just answering yes or no right here. You've answered yes, and thus you are resolving. Yes, I get now. Exactly why we use zeros and ones, because they indicate. It's like a light switch. It's like binary on-off light switch. Sound like a computer, like I can't sound like a computer.
Binary.
There we go. That sounds like a computer. So understanding why we do it, because it is either low humidity or it's not low humidity. And if it's not low, it's not moderate, then it's high. And that's the way to indicate. You don't really indicate it's high. It's just that it's not low, it's not moderate. Thus, it has to be high humidity because it's not those. It's process of elimination. And that's why we have a reference level. But yeah. Well, good stuff. Any other questions, Parker? With 1D, that's a lot of 1D right here. So what's the difference between, we did those right here. So between moderate and low, if you want the difference between 2 levels, you can just subtract them. Hints for those. If it's not the reference, fit them all, predicting demand from all your predictors. Woo! This going to show? Woo! A lot of variables. A lot of significant wind speed, yeah, and temperature. Awesome. Well, Parker, we're going to be doing some 475 here in a moment. We might end a little bit early. Going to grab some lunch. But thank you, everyone. We did a little 320 today, a little 201. Any other last questions? But I hope this helps you out a good bit. We probably did what, like 20-25% of the assignments, so some good stuff. You're welcome, Parker. Let me know if you have more questions. Might head off here for a moment because I'm going to grab some lunch. But great work. Had a lot of meetings today. Awesome work, Parker. We'll head off here. If you have questions, always remember, put them in the chat. We'll be back here in a little bit for some 475. Bye for now, everyone. Bye. Time for class.